Hello, and welcome to the launch of SimCenter FEMAP 2021. My name is Mark Sherman. I'm the Director of Software Development for FEMAP, part of the Siemens Digital Industries Software SimCenter portfolio. We have a 30-year plus history of providing our users with the tools required to accurately model the structural, dynamic, and thermal performance of complex engineered systems. Version 2021 is all about maximizing FEA efficiency. Joining me today is Andy Haynes. Andy is our Applications Engineering Manager, and he'll be walking you through several of the new features in our latest release in just a few minutes. First, I'd like to shift gears, though, for a couple of minutes and talk about digital transformation. It's clear when we look around us, people are looking for a better future with more personalized and safer products, reduced emissions, waste, and material usage, improved energy efficiency, and operational performance. Therefore, and fueled by technology evolutions, product innovation is at an all-time high, and we are confronted by an explosion of complexity to cope with those expectations. Compounding the situation are the conventional pressures of time, scope, quality, and cost. However, in the face of increased complexity, these pressures are even more challenging to navigate. Accelerator is our comprehensive integrated portfolio of software, services, and an application development platform. The portfolio accelerates the transformation of businesses into digital enterprises and unlocks a powerful industrial network effect, essential requirements to leverage complexity as a competitive advantage, no matter the industry or company. SimCenter, a key part of Accelerator, is a flexible, open, and scalable portfolio of the best predictive simulation and test applications that support customers at every step in their digital journey. The portfolio covers the full breadth of methodologies for engineering, covering system simulation, mechanical simulation, CFD simulation, electromagnetics, and electronics cooling and physical testing. And inside of SimCenter is SimCenter FEMAP. FEMAP brings a mesh-centric FEA analyst toolbox to the portfolio. We do this with specialized geometric functionality, support for a wide array of materials and element types, quality meshing, and intuitive tools to apply real-world loads and boundary conditions. This allows you, the analyst, to leverage the full power of commercial FEA solvers, including Nastran, Ansys, Abacus, and Dyna. FEMAP is a truly open system with a powerful application programming interface to interact with other software products, add custom functionality, and to automate repetitive tasks. Let's take a look at some very interesting companies leveraging SimCenter FEMAP. The Jet Propulsion Laboratory is one of our oldest FEMAP customers, having used the software for the past 30 years. FEMAP was first used at JPL in an effort to unstick an antenna on the Galileo space probe. More recently, as you've seen in the news, FEMAP's been used on Curiosity and Perseverance, the rovers on Mars. I'd like to now introduce you to my friend, Power FEMAP user, Jim Jeans from Structures.Aero.
Thanks, Mark. I'm Jim Jeans, owner of Structures.Aero. We're a small consulting firm located in Northern Virginia. We have 18 engineers, and we specialize in the design and analysis of composite aircraft and spacecraft. Most of our engineers use FEMAP every day in the work that we do. The program I'd like to talk about today is Falcon. It's an internally funded, small general aviation aircraft that seats 6. It's designed and analyzed by us. We're using FEMAP to analyze the structure, and we're slowly working towards FAA certification. We're currently building major subassemblies, and we're working with another partner on the construction. Another project I'd like to talk about is the NASA Roman Space Telescope. NASA is developing this telescope to provide better pictures than Hubble because this telescope will dedicate more of the light collected to the wide field instruments, which generates the pictures that we get to see from Hubble. So that this will greatly enhance what we can see in the future. Telescope uses a lot of composite materials, and we're using FEMAP to do the analysis of those materials. My team of 4 is doing large assembly models and all the way down to numerous detailed models where the coefficients of thermal expansion and the expansion of the material drives the design, and we have to prove that it's okay. Most of the team at NASA is also using FEMAP on this program. Another project I'd like to talk about is the Turbine Legend. The Turbine Legend is a small general aviation aircraft, seats 2. It is extremely fast and agile. It has many customers interested in it for its speed and its agility. It's built completely out of composite materials, and it was built in the 90s, but now we're reanalyzing it to use more modern construction techniques. We're also doing a pressurized version of this aircraft for our customer. The features coming out in the new version of FEMAP 2021 that we're most looking forward to are the mesh-on-mesh capabilities. We frequently get models that require us to remesh, and we don't always have geometry. So having the ability to generate a new mesh based on an old mesh is going to be very helpful for us. The new mesh propagation commands are similar, where we have to deal with models where the geometry just isn't very easy to work with, and having the new features are going to be very helpful. Thanks for the opportunity to talk about my company, Mark, and back to you.
Thank you, Jim. That was fantastic. It's always great to see real-world applications of the software. Now, I'm going to turn this over to Andy Haynes. Andy's going to give you the details on the new version of FEMAP.
All right, thanks, Mark. What we're going to go over now is a little bit about some new meshing technology, some advanced support for solvers that we have, and a little bit about JT visualization. The mesh sizing propagation functionality added for version 2021.1 limits the need for extensive geometry cleanup and manipulation to create a fully connected mesh. This same technology also enhances SimCenter FEMAP's interactive meshing tools to streamline creation of a high-quality shell mesh or modify an existing hex mesh. So the first thing we're going to talk about today is our new mesh size propagation technology. So as you can see, this is not one single piece of geometry in here, but it's actually several different pieces. Now normally we could non-manifold add this together, but non-manifold add often brings with it some issues. So what we can now do instead is we can come over to our meshing toolbox and we can actually see how these different pieces of geometry are aligned with one another using our new Mesh Control Explorer tool. So we can kind of see from here, we can see edges paired by mapping and proximity. We can see free edges, and we can see edges that are aligned and adjacent to one another, but that are not of equal size. So basically, this is where we might run into some issues. So what I can see here is I can come along and see different places where these edges are aligned, but maybe not the same size. What I can do is I can do a right mouse click on any different pair or number of curves that are all together, and I can do imprint points, or I can just simply do imprint points all, which I'm going to do. Once I do that, if I end up now showing my free edges, I can see that that is exactly what I would expect from this geometry if it was all non-manifold added together. And if I come to see which ones are not properly paired, there's nothing, now there is nothing to show. So I'm going to close my Mesh Control Explorer, and I'm now going to come over to my meshing toolbox, and I'm going to go to Meshing Surface. I'm going to just select all my geometry, say OK, and I'm going to get a default mesh size, and I'm just going to put a free mesh on this to start off with. So I'm just going to say dialog select OK, and all my geometry has been modeled, and if I actually take a look at the free edges, you can see I have a properly connected mesh. Just going to come back to drawing the model for a second, and what I'm going to do now is I'm actually going to just change this to map mesh, and I'm just going to change my size. I'm just going to reduce my size a little bit. Going to pick all of my surfaces again, and now you can see that we're going to end up with a completely mapped mesh, but again, none of this geometry was connected beforehand, so it was doing it all based on proximity. Now, another thing that we can do with the new mesh sizing propagation is now we have the ability to update a hex mesh. So the way we can do that is we can use the mesh sizing tool. So we can just simply increase, the size along a curve to see what'll be happening. We could decrease, we could set a number, we can set size. This is actually a new option for version 2021.2. So I'm just going to come here and pick one, and you can see that it's just going to automatically update the hex mesh. And then the other tool that we have is Mesh Surface. So we're going to come in here, we're just going to enter a mesh size of 0.15, and I'm just going to change this to map mesh. And now if I were to pick this free mesh surface, you can see that it's now going to put a mapped mesh on this surface, and it's going to push those hex elements all through my model. And that's what's new for mesh size propagation in FEMAP 2021. Version 2021.2 now offers the mesh bodies and mesh-on-mesh commands, which leverage meshing technology developed for other Siemens DI software products to create a higher quality mesh. For geometric bodies, this is done by imposing fewer sizing restrictions than our traditional meshing process. If geometry is not available, an existing mesh can instead be used as a starting point for a meshing workflow aimed at improving overall mesh quality. Okay, so one of the reasons that we added the mesh bodies command is because more and more we are getting geometry that has facet-based representation for surfaces instead of boundary or B-rep representation for surfaces. This happens to be one of those models. So if I were to take a look at the facets on this piece of geometry, even though it looks like a B-rep, it's actually a piece of faceted geometry that looks like this. Now what we can do is we can use our new mesh bodies command, and we have a number of options in here. We're going to actually be making a TET mesh, but we have some options on the geometry tab, curvature proximity tab. We're actually going to turn on proximity refinement and do elements across two. A tab that is for mesh quality, and then one to specify some TET options. So we're just going to come over here, and we're actually going to specify a target element size, and this is really the power of the mesh bodies command. Is it's just going to use this as a target element size instead of a very stiff and rigid element size like we do in the other mesh geometry commands. So I'm just going to set a value of 3 there, and I'm just going to click OK, and you're going to see it's going to be able to mesh on top of these facets or this faceted geometry, and what it's going to come up with is a very nice tetrahedral mesh. So we're just about to finish, and we're actually going to be able to see the quality down here, and our worst TET element quality is going to end up being around 7.187. It's going to turn the geometry off, and you can kind of see how nice that tetrahedral mesh is. Now, Nastran needs, as long as your elements are are under 100, you're good to go. So worst collapse of 7.187 for a model like this, that's pretty good considering we started with those facets. Now, another thing that we can do with this new meshing technology is we can actually use the mesh-on-mesh command. So what we're going to do here is we're going to select elements to mesh by property, and we're just going to select these elements that are here. Oops, not those, but let me get rid of that. But these, I'm going to say OK. And a lot of the same options are available on these tabs, but what we're going to do is we're going to change our target element size. We're going to make this larger. We're going to change this to 0.25. So we're actually going to do a bit of an unrefine. So this is actually going to keep basically the model is going to remain the same, but we're going to get larger elements on this portion of the model, and they're going to be of very high quality. So here we go. You're going to see that we're going to end up with just some really, really wonderful looking quad mesh on that particular section of this leading edge model. Extensive support for MSC Nastran's implicit nonlinear solution sequence, Solution 400, was added for SimCenter FEMAP 2021.1, which includes the ability to specify contact conditions, advanced materials, property extensions, and unique analysis parameters. Furthermore, analysis chaining, specified using the new analysis step and global step entities in the analysis set manager, allows Solution 400 to solve the multi-physics problems facing many of today's analysts. Okay, so here we have a model that we're going to set up and run in MSC Nastran Solution 400. So one of the first things we're going to do is we're going to take a look at the connection property. We're going to come in here, and this is the MSC Nastran tab. So for 2021.1, we actually added some additional options, including the interference options down here to specify interference and gap options, as well as some additional contact parameters here. And then we actually already had this that existed before in terms of contact. For materials, if we were to make a new material, you can use the nonlinear tab to specify a lot of the different nonlinear parameters for solution 400. But you can also come over here to material type, go to other types. And what you can see is we've added some additional MSC Nastran specific materials that are good for solution 400, including these hyperelastic materials, this cohesive material that allows us to make cohesive elements, and the support for the MSC Nastran gasket material. For properties, we actually added an entirely new icon, which allows us to access property extensions. So basically, each solver that has a property extension has its own tab. In this case, solids only have one for MSC Nastran. So you can turn on the large strange formulation, and then you actually have options for integration type and behavior type for each different topology of solid element, and then a material override. Finally, what we're going to do is we're going to come in here to the analysis set. So we're just going to go to analysis set. So we have a couple of options here. We have the ability to specify options for nonlinear behavior, automatic contact parameters. So this will actually do automatic contact generation for you for solution 400. You can come in and just do standard contact parameters. Again, you can turn this on, and we have also now added options for cohesive contact. So you can just cancel that. I'm just going to cancel out of there. I'm just going to come down to our case, and you can see we have control parameters. So you can turn this off, so you can actually choose a nonlinear type between default, linear, mildly nonlinear, or severely nonlinear. You can say OK. And then you can also specify cases. And this is, analysis steps. And steps, what they allow you to do is the analysis chaining that was mentioned earlier. So you can just come in here, you can edit this, and you can choose whether you want to just specify the step or use a global step, which you can basically specify using the step manager here. Done. So I'm just going to cancel out of all this. And then basically what this allows you to do is run a job like this, where we can just come into our analysis study, right mouse click and say animate the study, and then we can turn on a contour plot here. And just so we can take a little bit closer look, I'm just going to turn off that top roller so you can see this is the type of analysis that solution 400 in MSC Nastran allows you to do. SimCenter FEMAP 2021.2 addresses a long-time request from customers by offering the ability to specify subcases for transient, frequency, and nonlinear transient response. This can be used to specify frequency, time step, or nonlinear parameters in different dynamic subcases, or account for stress stiffening and optionally impose contact conditions using a static subcase. All right, so now that we support being able to create analysis sets with subcases for dynamic analysis, once you have a model set up properly to run a frequency response or transient response or a nonlinear transient response, you basically can just take an existing one or copy an existing one of those or make one from scratch to be able to specify these subcases. So I'm just going to do model analysis, and I'm going to say new, and I'm going to go to SimCenter Nastran, and I'm going to be making a frequency response harmonic analysis. So what we are going to want to do is come in here to our dynamics tab, and we're going to want to go here and change our solution type to modal, then come here and make sure that we do not have any response frequencies specified for the global level case. And then I can come down here to no cases defined. I just say new. I have a choice between static or frequency harmonic response. I'm going to say static. I can just click next. Then I can pick my loads. So I'm going to pick my bolt preload as my boundary condition, and I'm going to say OK. At this point, I'm going to want to make a dynamic subcase, so I just click on my existing subcase, click New. This one's going to be specified as 4 frequency harmonic response. It's going to say Next. I'm going to come to my dynamic analysis dialog box, and I'm going to turn on my 2 sets of response frequencies. I'm also going to come over here to my options for dynamic analysis, and you specify a modal damping table. I'm just going to say OK, and then say if I wanted to do Next, this is where I now applied my dynamic excitation. Come to Next, and if I wanted to specify some Nastran output requests that would only be for this particular subcase, I could do that as well. I'm not going to do that though. Just going to say OK. Now, in order to use the static subcase, in order to have the dynamic subcase use the static subcase, what you have to do is you come in here and you choose the stat sub, and you click Edit, and I can just now choose my original subcase, my static subcase, as my preload subcase, and I can say OK. And then I can just do a preview input, and now you can see that I have a subcase that has a load and a bolt load in it. Then I have a subcase 2, which is my dynamic subcase, which has stat sub, a deload, my damping, and my frequency range specified. Done. And what you can do once you have results is you can just come here and we could take a look at the plots of T3 accelerations, T1 translations, or any other quantity that we recovered from our multi-subcase dynamic analysis. Finally, version 2021.2 can now be used to create JT visualization files, which contain additional CAE entities or results from multiple output vectors, which can be used within the Teamcenter for Simulation product or another JT collaboration tool to visualize, model data, and review results without the need to open an instance of SimCenter FEMAP. All right, so the last thing we're going to talk about today is the creation of JT files. Now, you've been able to create a JT visualization file from FEMAP for a while using File, Picture, Save JT. But we've added some options. The very first thing we have to do is specify a file name. So I'm just going to call this one multiple. And then it's going to take me over into my JT file options dialog box. So when it's set to standard output, it'll be able to send the output vector currently being shown in the screen along with visible, active, all, or selected load sets and constraint sets. We can also specify a JT hierarchy, and we can draw any lines that we want to as cylinders. But what we're really going to look at, and this is what's really interesting about this new version, is multi-result output. So we can send it either as raw output data directly from FEMAP. That would basically be like taking the data from Nastran and sending it over, or as collated vectors and tensors, which is what we're going to choose instead. So what we're actually going to do is we're going to click the Select Output button. This is going to bring up our typical Select Output dialog box. So we're going to select all our output sets. I'm going to choose Total Translation. And then I'm just going to use a filter real quick to just get some von Mises stress in here as well. So I'm going to grab plate top, plate bottom, and solid von Mises stress. So I'm just going to click OK. And then I'm going to say OK. And it's going to now create a JT file for us. And once the JT file is created, we're actually going to go over into Teamcenter Visualization Professional version 13.1. So we're going to do a File, Open, and we're going to choose this multiple JT file. So once it's opened up over here in the Teamcenter Visualization portal, I can rotate my model. You can see that all of my different output sets I selected are available. So I'm actually going to come down here. Let's just take a look at solid invariant stresses. We'll take a look at maybe some von Mises plate stresses. And what I'm finally going to do is just come down here to nodal displacement, and we're just going to do an overall magnitude instead. So basically, now we can take a look at total translation on our entire body. And again, I'm doing this all without needing to use an instance of FEMAP. Now, if I come here to the Render tab, I can, come over to Display Options. I can turn on Deformation Display, and then I can just go to Configure, and I just can see that my result is yes, nodal displacements, and my component is magnitude. I'm just going to say OK. And once I hit Apply, you can see that I can now take a look at my deformed model inside the Teamcenter visualization tool. Okay, now back to Mark to wrap things up.
We'd like to take this opportunity to encourage you to engage with Siemens experts and other users on the SimCenter community. The link shown here will take you to the top level of the SimCenter community, where you will find links to access the blog, knowledge base, and discussion forums for various products in the portfolio, including SimCenter FEMAP. And lastly, for those of you who have not tried FEMAP, you can do so for free. All of the new capabilities that we've discussed today are available in our trial. It's a full software version. You download it at the link shown here. All right, we got some questions here rolling in online. We had stuff about version 2021, but I saw .1s and .2s. What's the difference between those versions and which one has what? Yeah, we did talk about the full 2021 releases today, which is actually a .1 that came out in December, and then the .2 that's out now. Some technology actually was put in .1, has been expanded in .2. Most of the stuff we talked about is like that, but the new body meshing stuff, that's brand new. You're only going to see that in the latest one, 2021.2. Next, oh, here we go. Well, when will it exactly be available, 2021.2?
I'll take this one, Mark. So it's available now for download from the Siemens Software Center, like a lot of the past versions of FEMAP. One point we'd like to make while we're talking about distribution is we've been clear that it's time to move on away from shipping DVDs. And well, this version of FEMAP, this is, and all future versions of FEMAP will be available only from the Software Center. So no more DVDs. Again, it was time to move on.
All right, got another one here. Mesh bodies command uses different approach for meshing than commands on the mesh geometry menu, and I heard some workflow stuff. So, what are you guys talking about there? I guess the whole point of the mesh bodies command is that it is slightly different in process. So in traditional FEMAP, you always put the node, you specified exactly how many nodes would be on a curve and things like that. The new mesher does its best job when it's able to move those nodes around, and it might even move them off of curves and surfaces. So it's not actually possible to associate exactly back to the geometry, but it does get you a better mesh. With that in mind, though, if there are loads and boundary conditions specified on geometry, you're going to get an exact mesh there matching things and have it associated. So the main workflow difference and the best practice, if you're going to use the new meshing technology, just set up your contact, set up your loads, and set up your boundary conditions first, and then do the meshing. Another one, it's about JT output. Haven't really used that before. What's it good at? What's its strengths?
Mark, I'll take this one. So, JT's biggest strength is in the democratization of CAE data in large enterprises. So, essentially, the JT data created is used to convey CAE results or what have you to non-CAE consumers, typically in a Teamcenter managed data environment. So essentially, again, as we showed in the demo, you can just have anybody open up a JT file in the Teamcenter environment instead of having to use an extra seat of FEMAP.
All right, hold on, one more. Can I use the new mesher technology with traditional FEMAP surface meshing? The answer to that is yes. We've actually put under mesh surface where you had multiple options for triangle meshing and quad meshing. There's now a new option to use the body mesher. Now, it's not to its best advantage because the node locations are fixed when you go that route, but we have seen some really nice meshes, especially with transitions. The new body mesher is real good at transitioning from a real tight mesh to a coarse mesh, so sometimes you actually might want to use it in the traditional workflow. Thank you for joining us today. We do have moderators standing by on YouTube and Facebook, where we'll be formally answering questions for a little while. So you can continue to ask those questions well after. Thanks again for joining us. I think you will find SimCenter FEMAP 2021 to be a great release. I'm looking forward to see what you do with it.